So our last video is on adding and subtracting fractions with unlike denominators. So looking at our first example, our denominators are in factored form and they don't have anything in common. So we've got to multiply our first one by 2x plus 5 over 2x plus 5. And our second one, we're missing the 3x minus 1. So in the numerators, we're going to distribute our 6x, and we have 12x squared plus 30x. This I'm going to change to a negative 4, so don't forget about my subtraction. Distributing my negative 4. And in the denominator, I leave it in factored form until I know if the numerator factors after it simplifies to see if I can cancel any more common factors. In my numerator, my 12x squareds cancel, so all I've got is 34x, which does not simplify with anything in the denominator, so I'm going to go ahead and multiply, put that in standard form. We've got 6x squared minus 2x plus 15x minus 5. And the domain restriction, looking at our factored form, setting 2x plus 5 equal to 0, x cannot equal negative 5 halves. And setting 3x minus 1 equal to 0, x cannot equal 1/3. One last example, again with no common factors. So I'm going to start by multiplying this by 2x minus 5 over 2x minus 5. And my first fraction, I will multiply by x plus 3. So I need to distribute in the numerators. Again, I'm going to leave my denominator in factored form. My first numerator distributes to x squared plus 3x plus 12x, or 15x, plus 36. My second one distributes to 6x squared minus 15x minus 4x plus 10. Again, leaving my denominator in factored form. Simplifying my numerator, I have 7x squared minus 4x plus 46. And to save you a little bit of time, I already checked this one. If it factored, it would be the AC method, and there is nothing that multiplies to 322 and adds to negative 4. So our numerator does not factor, which means I'm going to go ahead and put our denominator in standard form. Multiplying, I've got 2x squared minus 5x plus 6x minus 15. Last piece, finding that domain restriction, looking at our factored denominators. X cannot equal negative 3, setting x plus 3 equal to 0. And x cannot equal positive 5 halves, setting our 2x minus 5 equal to 0. And your U-try problem.